So hello guys, once again we are up with a new session, and that is based on our today's session is based on VCRS, vapor compression refrigeration system. One of the most important topic we'll be discussing, and so let's get start with the Dreamer package technical discussion, that is refrigeration system. So the format will be like this, guys. I will be asking one by one to everyone in the meeting, and guys, you have to try. Okay, and nothing matters if you say something wrong, or we will be discuss and will correcting it. No matters. Anyway, you will be learning. And so, guys, without wasting any time, let's get started. And the new people coming from Telegram group can join my WhatsApp group. I have just sent it in here. So as you know, the today topic is VCRS. So I will be asking explain vapor compression refrigeration system. Okay, so the first, Sarfraz, would you like to go ahead?
Yes.
Okay, so better to open up your camera if you can, then it will be good. Are you opening up your camera?
Bro, if I need to open the camera, then I need time. So let's carry on like this.
Okay, anyone who is ready to open camera and can speak? Salman, are you ready to open up your camera and try to speak up? See, because this will also help in your showing your body language.
Yes, yes,
Okay, so
yes,
Salman, go
sure.
ahead. Open up your camera, and your question is explain. You have to fully explain all the process, stages, and all. Explain VCR cycle. They will interviewer will ask like this only. Let me pin you. Okay, so me and you. Okay, so Salman, explain VCR cycle.
VCRS is a vapor compression refrigeration cycle. In VCRS, the working fluid is a refrigerant. In VCRS cycle, the four major components are the compressor, condenser, expansion device, and the evaporator. In the compressor, isentropic compression of the refrigerant takes place. In the condenser, heat rejection at constant pressure takes place. In the expansion device or the thermostatic expansion valve, the isenthalpic expansion of the refrigerant liquid takes place. And in the evaporator, the refrigerant absorbs heat and at constant pressure. So this was an overview to show how the flow takes place. After compression takes place in the compressor, the refrigerant is in a superheated state where it has a high temperature and high pressure. This refrigerant then goes to the condenser and undergoes a condensation process, and by the time it exits the condenser, it has a slightly lower temperature, but the pressure is the same. After the condenser, and it is in liquid state. So this refrigerant liquid then goes to the expansion device or the thermostatic expansion valve. But before the thermostatic expansion valve, there is a dryer placed. This dryer is normally silica gel or activated alumina. The dryer is placed before the expansion device so that if there is any moisture present in the refrigerant liquid, it doesn't freeze in the expansion device and clog the passage of the expansion device. In the thermostatic expansion valve, since the area is significantly reduced, so the velocity of the liquid refrigerant is increased and the pressure is significantly reduced. Since the pressure is reduced, So some of the liquid refrigerant vaporizes by absorbing its latent heat of vaporization, and in the process also causes evaporative cooling of the surrounding liquid. As a result, the temperature of the refrigerant is also lowered. So at the exit of the expansion device, the refrigerant is having low temperature, low pressure, and is in liquid vapor mixture state. This refrigerant then goes to the evaporator, where it absorbs heat from the refrigerated space and undergoes phase change. By the time it exits the evaporator, 100% of the refrigerant is converted into vapor. This refrigerant then goes to the compressor and the cycle is completed. Now to make sure that 100%, now to make sure that no liquid goes to the compressor, because if liquid goes to the compressor, then it will damage, it is incompressible and it will damage the compressor. So a sensing bulb is placed at the exit of the evaporator, and it is connected to the thermostatic expansion valve via a capillary tube. This arrangement makes sure that 100% of vapor enters the compressor. And to be and for safe side, some amount of degree of superheat is given to make sure that no liquid enters the compressor. This was about vapor compression refrigeration system.
A big clap for you. You have just passed your this question interview. Like if it will be asked and you will say like this, a little polish is needed only. So Salman, that was very nice. So my cross question to you is that what is the temperature at evaporator coil?
So the temperature at the evaporator coil, it varies from refrigerant to refrigerant, and there are other factors as well, but the two major factors are the type of the refrigerant and the application. So normally the evaporator temperature for R134A refrigerant is minus 18 to minus 20 degrees Celsius, and the and for example,
Your voice all of sudden, oh shit. Yeah, the last which I heard, Salman, are you there? Sorry for network has gone. The last sentence I heard
yes,
is that minus 18 to minus 20 degrees Celsius, and that is depend upon the type of refrigerant. Would you like to go again, like carry the whole concept?
yeah. So it not only depends on the refrigerant used, but the application as well. So for like in case of domestic refrigerators, so it will be around minus 15 to or minus 18 to minus 20 degrees Celsius, where R134A refrigerant is used. And in case of air conditioners, where the temperature of the refrigerated space is higher, so there the temperature is around like 5 to 15 degrees Celsius.
Okay, what is the vegetable compartment temperature for evaporator coil at evaporator?
It is around 4 degrees Celsius,
Okay,
4 to 5 degrees Celsius.
okay. What is pressure at condenser coil?
The pressure at the condenser coil is for R134A refrigerant is around 10 bar.
10 bar. And what is pressure at compressor?
The pressure is same for condenser and compressor at exit of the compressor.
Okay, and for since isobaric, okay, and why this temperature is changing? Why, what is compressor? First tell me what is the compressor temperature and what is the condenser temperature for R134A approximately.
Compressor temperature is around 50 degrees Celsius, and after the condenser, since it is having some degree of superheat, so then the temperature is reduced to around 30 to 35 degree Celsius.
Okay, a big thumbs up for you. Now,
Thank you.
uh, you have passed your written right now.
I've SIMS. I've cleared SIMS written. No, no, I've just given SIMS, but result is pending.
Okay, what about Anglo written?
Actually, I have applied for Anglo thrice before, but I was rejected.
To whom? By whom?
Briganza, sir.
Oh God! Now the people who are seeing from my top 30 questions and answer session with Everto Lorenzo. I just finished the Brajanga sir hype sorry hype. All the thing which Brajanga sir asked and how he take the answer, how he liked the answer delivery of answer. So there are 3 to 4 guys who faced after uh, studying from that lecture. They just solved it. They just got selected by Brajanga sir. Got it? So Salman, so you lost your chance for Anglo. You are having IMS Goa.
Yes, SIMS and IMS Goa.
Okay, okay. So best wishes for IMS Goa and SIMS. Okay,
Thank you.
okay. And now, Sarfraz, you are ready with your camera?
Yes.
Just open up your camera. Mhm. So, Sarfraz, explain VCR cycle.
Okay. The vapor compression refrigerant cycle has 4 main components: the compressor, where isentropic process takes place; the condenser, where heat rejection takes place, that's the isobaric process; the thermostatic expansion valve, where isenthalpic expansion takes place; and the evaporator, where heat absorption takes place, that is the isobaric process. First, the refrigerant gas gets into the compressor, where it gets compressed. First, the low pressure and low temperature refrigerant gas gets into the compressor, where it gets compressed, and now the pressure and the temperature increases. Then this refrigerant gets into the condenser. Superheated refrigerant gets into the condenser. The condenser has seawater lines in it. It acts as a heat exchanger. When it passes through the condenser, it undergoes condensation and the state transfer takes place. It changes into saturated liquid and a slight pressure drops takes place. Then it passes to the dryer. The dryer has silica gel in it, which absorbs the moisture present in the refrigerant gas. And then it goes to the thermostatic expansion valve. The thermostatic expansion valve is a throttling device which regulates the flow of refrigerant into the evaporator, and it has an orifice. And when the refrigerant passes through the orifice, a sudden pressure drop takes place because of the increase in volume. Because of this pressure drop, the temperature also decreases, and then it goes to the finally it goes to the evaporator. The evaporator also acts like a heat exchanger. The refrigerant absorbs the heat from the refrigerant area and cools down the refrigerant space, and it changes its phase into wholly vapor refrigerant. And towards the discharge side of the refrigerant evaporator, there's a sensing bulb which is connected to the thermostatic expansion valve through a capillary tube, which has the same refrigerant that is flowing inside the main refrigerant line, and it responds to the degree of superheat. And whenever the degree of superheat is more, it signals the thermostatic expansion valve to increase the flow of refrigerant into the evaporator. And whenever the degree of superheat is less, it signals the thermostatic expansion valve to decrease the flow of refrigerant into the evaporator. It's done.
Okay. Well tried, Sarfraz. It can be much better, okay, but it was quite enough to
Yes.
if the interviewer is not Braganja sir. Okay. There are something you lacked, okay. that while explaining thermostatic expansion valve, you forgot to explain this after from saturated liquid, after saturated liquid from condenser, when it passes through thermostatic expansion valve, it becomes the mixture of liquid plus vapor refrigerant. That
Mixture, yes.
okay, you forget to mention that Salman mentioned, and after he
Yes.
also told in explained that why this mixture is becoming, because some of the liquids takes out the takes the latent heat of the remaining portion of the liquid and evaporate, so the temperature also decreases. Okay, so this, so a quite detailed explanation will make your possibilities more higher. And same, the cross question is, what is the temperature at evaporator coil?
It varies from refrigerant in the type of the refrigerant. It depends on the type of the refrigerant, and mostly the most common refrigerant that is in use is R134A, and for it the temperature should be -18 to -20 degrees Celsius.
What is the pressure at condenser coil? What is the pressure at condenser coil?
The pressure at condenser, 10 bars.
And at compressor?
After the discharge,
Yeah, what is the refrigerant pressure at compressor, like after getting compressed?
okay, minus 19 or 19 or 20 bars.
See, the concept is very much important. Salman, as Salman said, the pressure will be same at condenser and compressor. Okay, at the same time he mentioned that it will be since isobaric is taking place after compressor, the refrigerant is going in after compressor, refrigerant is
So
going
into
in,
the condenser.
and condenser, which type of process is taking place? Isobaric process. Isobaric process means
Isobaric,
pressure will be
it means
constant.
constant pressure.
Whatever will be the pressure will remain same. Okay, got it? If the pressure is at compressor is 10 bar,
Okay.
then the
Yes,
at
yes.
condenser it will be also 10 bar. Same like in a case of thermostatic expansion valve, after thermostatic expansion valve, where refrigerant goes in in
Into the evaporator.
evaporator. And which type of process is in evaporator? Which type of process it is?
It's
Isobaric.
isobaric process.
Isobaric.
Isobaric heat absorption.
So pressure will constant. So whatever the pressure after TEB, that is approx 4 degrees Celsius generally. So the 4 degrees Celsius would be like this at evaporator for vegetable compartment. Okay. So sorry, I just misspoke. Okay, I am talking about pressure now. Okay, so 1 bar pressure
4
is
bars pressure. Yeah.
1 bar pressure. Okay, atmospheric pressure. Got it? Many of the people are leaving
Okay.
that. Okay, why is that?
Yes.
Okay, so you are getting it, the concept behind it. And so you haven't went through this latest videos which I have uploaded today?
Yeah, I haven't seen the latest video.
Okay,
Yesterday I have seen the other one.
okay, that's why you lagging. I have just uploaded
The whole
today.
explanation of yours.
Yeah, I have just uploaded the latest video in which the concept of temperature, pressure and all the things
Okay.
you'll get to learn. Okay, and so well explained.
Okay.
I will get back to you with the another explanation. We will be asking some more question. Till now I am asking this question only. Now who would like to go again? Amston. Now Amston,
Okay.
try. No proper network. All right. since Jack is from, sorry for that. You can use your voice also without any, but since see, I don't want to feel any shame or any fear. Okay, if you will oh, okay, he will be joining again. Then who would like to join? Srikant? Okay, Amson, you can use your voice only to explanation. If you cannot use that also, no problem. Okay, but later on whenever your network will free, you have to give yours to me or Avito your explanation. Okay, so I'm Harish and Srikant and James Colasso. Anyone would like to go ahead with the VCR explanation? Am I audible, guys? Avito, am I audible?
Yeah, audio is perfect.
Okay, so Srikant bro, I'm Harish. You people are new joining. If you are new joining, join my WhatsApp group. Okay, no worries. I think Amston, you are facing network issues. No worries. Srikant, James Colasso, it's a last call I am asking. Otherwise, I will be carrying on with the Salman Sarfaraz, who is and Jackpot is marine engineer guy. So if Jack would like to explain VCRS cycle, he can explain. Otherwise, actually, I am new to this. Explain later.
No, bro, you can carry on to the next question.
Okay, okay. Uh, what I got from Srikant sir. Actually, I am new to this. I will explain later. If anything you know, I think you must have passed your mechanical, because guys, what why I am here to make you shameless, to make you enough confident that if you don't know anything but you know little of the things, but confidently you say that. Okay, because it will create a difference in other will fear, who will hesitate, and you will just clear that. Okay, so if you know, Srikant, something, even the process only, you can use your voice.
Yeah, okay,
Oh,
sir.
okay, all right.
VCR is the definition for this is vapor compression refrigeration cycle, where it is used to cool the materials for refrigeration. And in this process, there are four mechanical equipments are involved. One is compressor, second one is condenser, and expansion valve and evaporator. In compressor, generally the refrigerant will enter and it will change its temperature and pressure high, and after that it will enters into condenser where there is at high temperature and pressure there is a phase transfer will happen. Means little bit of vapor is converted into condenser. That high temperature and pressure condensed refrigerant will enter into expansion valve. From expansible, it will be converted into low temperature and pressure vapor refrigerant. This refrigerant will goes to evaporator. In evaporator, there is hot air will come from that surrounding areas that low temperature and low temperature that will change into low vapor pressure. I think.
No worries, no worries. I will be telling you where you left. Okay, so
So,
conclude.
uh,
Okay, so after evaporator, it will take
after observing heat from that
surrounding
in evaporator,
surrounding the phase change
yes,
will
sir,
take
in
place.
evaporator surrounding heat will absorb that refrigerant. It will change vapor state,
It
and
will,
that vapor will enter again into compressor. This process is
so from
continuous process. It
yeah.
is.
See, you were not explaining, you just explained 70% of the things, isn't Ayoto? He was not taking a charge, but now he
Yeah, sir.
explained 70%, only 30% he is lacking. And So this is the difference, Srikant. Okay. So where you lacked, there are some things, a minute
Yeah, yes, sir.
details.
The terms also I don't know actually.
Hmm? Yeah. What? What?
Actually, I didn't went through Dreamer package also.
Okay. You are having Dreamer package or not? If not, I can provide you discount code, coupon code. Okay. After
No, sir.
the
No. No.
Okay, no worries. After completing
Yeah.
this session, na, I will comment. I will pin the in the comment box the link with the discount coupon code. Okay, you can refer that. Okay. So other than Srikant,
Okay, sir.
other than Srikant, James and Harish, anyway, any people? Okay, no worries. So I was saying that you lacked where you lacked just little minute detail, like when you will watch the videos from Dreamer package, you will you will feel that where you lacked. Okay, after you will be getting this recorded session also, and in future when you explain after watching from Dreamer package, I have also made a video lecture on that is on YouTube. You can refer to that also. Your explanation will be much better. Okay, this 30% which you are lacking will be finished off, and you will get a proper polished answer that will suit to interviewer. Okay guys.
Yes, sir.
Okay, all right. So if someone is joining new from Telegram group, please join my WhatsApp group. I have just shared my link. Okay. Now who is this putting on camera? Venki Vimana, are you from Telegram? Okay, so now the next question is, should I explain the VCRS, uh, or Salman and Sarfraz did was correct regarding that? So I should explain. Okay, let's after explanation we'll be explaining the further concept like what is saturation dome, and we'll be also discussing this why this thermostatic expansion valve at the saturated liquid refrigerant, why in thermostatic expansion valve saturated liquid refrigerant converted into mixture of liquid vapor refrigerant, and how sensing bulb ensure this, or also will be understanding the superheating concept. Okay, so before that let me explain how the VCR cycle works, VCRS full explanation. Okay, so for that I need to present my screen. Okay, I will be taking help of the schematic diagram for to understand from the clear picture. Salman, you went through
Yeah,
the latest videos, latest video which was based on.
Yes, yes, I
Okay,
did watch
okay.
your
How
latest
was
video.
it? It was understandable.
Yeah, from that only I got the idea. Yeah, it was nice. Yeah,
Okay.
it was nice.
Actually, this was very
Like
important
it
video.
gave those like concise information.
Yeah, and you know the same Mervin Braganja sir has rejected many people. Okay, from that question only.
He had asked me same questions in this
To me
discussion
also.
in the interview.
To me also, but I emphasized that it's not the exact value. I emphasized on that the concept that is based on which type of refrigerant we use, and other external factor, that what is ambient temperature, what is the which load, you just talk about the application, so for which thing we are using it, and other so many factors that covers the decide the temperature at evaporator coil, condenser coil, and all the things. And most common factor is that which type of refrigerant we are using, and most common refrigerant is R134A. Okay, and what is the chemical name of one R134A?
Tetrafluoromethane.
Tetrafluoroethane. Ethane, not methane. Ethane. He will trap you. Interviewer will trap.
Sorry.
Okay. Just your video. Everyone can see my.
Hello guys.
Okay.
Hello guys.
Now this is the schematic diagram. Okay. From here we will be starting. Okay. So, am I audible? Am I audible, guys? Let me confirm.
Yes.
Okay. Srikant. Yes, Srikant. What is your question? You just raised hand. Okay, all right.
Actually, I just raised to hand. That's
Okay, all right. Okay. See, my screen is visible, guys.
yes, sir. Yes.
Okay. So, how you will be explaining? First, you will be explaining like this to make easier that which type of process is happening in which component, or how many major components in refrigeration system, and how many stages. Okay, and so before that, let me tell you what is refrigeration cycle or VCR cycle. Okay, what is this cycle? This cycle is a thermodynamic cycle. As the thermodynamic means where heat transfer takes place. Okay, the change of state taking place. This is related with thermodynamic means thermo means heat, dynamic means motion, heat in motion. Okay, so this is a thermodynamic cycle that produces refrigeration effect and causes cooling. As you guys should know where the refrigeration effect is producing. Guys, where refrigeration effect is produced, in which region? Anyone?
Yes, we.
At which region in VCR cycle?
Evaporator coil.
Evaporator coil. So guys, in the mid I will be asking the cross question as well. Okay, you people have to show some activeness. All right, now see, and where the refrigerant serve as a working fluid that goes under the phase changes. Here phase changes takes place, here phase changes takes place. Okay, what are these? This condenser and evaporator are type of heat exchanger. Okay, and basically this refrigeration cycle involves four stages. That is compressor, compression. Which compression? Isentropic compression. You know guys what is isentropic? Entropy is constant. Here I have also made the graph. Okay, so let me move myself there. Yes, now the picture is clear. I will be telling you from the graph. Okay, so here four stages in refrigeration cycle. The first stage is isentropic compression. Here you are seeing the T and S graph. S means entropy, and 1 to 2 process is compressor. So it is constant. You are seeing that guys, if it will go like this, it will be constant. Temperature is increasing but entropy is constant. So compressor is a isentropic compression. Okay, in compression, isentropic compression is happening. After that, isobaric condensation or isobaric heat rejection. Here, isobaric means pressure constant. So we'll refer this P and H graph. Okay, P and H curve. That is 2 to 3. 2 to 3 is in this P is constant. Okay, isobaric heat rejection. P is constant. Heat rejection. Okay. Now, and at the same time we'll be discussing that why this pressure is constant but temperature is not constant. But we have also heard at the same time when the phase change takes place, the pressure is the constant, pressure will be constant, and that pressure will be known as saturation pressure. But at the same time temperature will be also constant, that temperature will be known as saturation temperature. But here we are seeing that pressure is constant and but temperature is slightly decreasing. We'll be discussing that also. But before that, understand the next stage. Next stage is isenthalpic expansion using thermostatic expansion valve. Isenthalpic means enthalpy constant, heat enthalpy constant. So from curve here we are seeing that pH curve, H is constant. So you are seeing that 3 to 4. Okay, this is constant. Okay, so thermostatic expansion valve, in thermostatic expansion valve it is isenthalpic expansion. Okay, now again the fourth stage is isobaric evaporation. See, pressure is constant, it is evaporator, isobaric evaporation, that is heat absorption. So guys, as you are also seeing that here when heat is absorbing, here you are seeing this H, pressure is constant but H is increasing, heat enthalpy is also increasing. So these are the external things you should also know, but the basic I was I was saying that there is a 4 stages. Okay, using 4 component. Okay, now we'll be studying the flow of refrigerant, how the actual refrigeration effect we get, how the cooling effect we get, how because of the flow of refrigerant and phase changing. So guys, now see, the cycle begins with the compressor. Okay, from here, this is the point 1. Here from graph, see this point 1, point 1. Till now everyone understand what I meant to say? Sarfraz, Salman, Amston, just give a
Yes.
revert. Okay, if any cross question you people ask in the mid also by halting me, no issues. So again, the cycle begins with the compressor. Here this is a 1, process number 1, here in T and here in PS curve, in PS curve you can see. So in that, where the vapor refrigerant at the low pressure, see this low pressure P1 and low temperature T1, this is T1, enters into the compressor from the evaporator, this is evaporator, to where it is compressed to a high pressure, high temperature, it is compressed. After compressing, temperature is increasing up to 2, after compressing pressure is increasing, here the second. Okay, 1 to 2, compressed into high pressure, high temperature, superheated vapor refrigerant. See this superheated, high pressure, high temperature, superheated vapor refrigerant. We discussed last time that the after saturation dome, this side if the graph is falling, okay, so this will be a superheated region, this is a superheated region, and the point 2 is lying at superheated. Okay, so this is superheated vapor, this is vapor region, and after it is some more having more temperature, so superheated. Okay, superheated vapor refrigerant. Now after compressor we are having high pressure, high temperature, superheated vapor refrigerant. Okay, now then this high pressure, high temperature, superheated refrigerant enters into the condenser. This is condenser, guys. It is a type of heat exchanger where this superheated guys, this point 2, this superheated vapor refrigerant rejects heat to the surrounding and changes its phase into a liquid refrigerant. Superheated refrigerant rejects heat. Rejecting heat means losing its enthalpy. See here, enthalpy is decreasing from 2 to 3. It's a condensation isobaric heat rejection process. 2 to 3 isobaric heat rejection process, where it is changing in, it is going under the phase change. Guys, phase change means it will cross this saturation dome. It is crossing or not from 2 days to 3. Here, see, 2 days to 3, it is going under the phase change. This is showing phase changing. Whenever this fall in saturation dome, phase changing, it means phase changing. Phase changing, that also covers the concept of saturation pressure and saturation temperature, that when phase change occurs, this pressure will be constant, okay, and when the pressure that falls in saturation dome, thus this temperature will be also constant, and this pressure and temperature will be known as saturation pressure, saturation temperature. For water, for example, for water, since water change its phase into a vapor at 100 degrees Celsius, so for water saturation vapor pressure will be 1 atmospheric pressure. So for water change its phase into vapor at 100 degrees Celsius at 1 atmospheric pressure. Many people say that it's change its phase into vapor at 100 degrees Celsius, but the important thing is to say at 1 atmospheric pressure. Okay, so this atmospheric pressure will be 1 atmospheric pressure will be saturation pressure, and this 100 degrees Celsius will be saturation temperature. So I meant to say that when water will be converting into vapor, this 1 atmospheric pressure will not change. At the same time, this 100 degrees Celsius temperature will also not change. Okay, so this is saturation and pressure saturation pressure and saturation temperature concept, and saturation dome concept. I just said that this is a saturation dome, this is a saturation dome. The saturation dome in which this region is superheated region, this region is mixture region in which you get liquid vapor mixture, okay, and this region is liquid region. Okay, yesterday we discussed this. Now where I was, superheated vapor refrigerant, this superheated vapor refrigerant rejects heat to the surrounding and changes its phase. Here changing its phase into a saturated liquid refrigerant. Guys, why it is saying it is, you must be seeing this point 3. This point 3 is what? Saturated liquid refrigerant. Is it or not? Because just below this it will come into the liquid stage. Okay, this point is saturated point, this point is saturated point, isn't, guys? Any problem understanding this point is saturated point? Okay, and it will happen at constant pressure and becomes a high pressure. Since constant pressure it is happening, so pressure will be high as it was in compressor, and so it becomes a high pressure saturated liquid and with slightly lower temperature. Okay, so here the temperature at compressor is this point guys 2, but temperature at condenser is 2 days. This will be T2 days. Got it, guys? Till now any problem, any cross question, any doubt to anyone? Salman, Sarfraz, Hifazat, anyone, guys? We are just after condenser. Okay, so after condenser we are,
I have a question regarding in condenser,
okay,
but not from this state transfer. A different question regarding condenser.
okay,
After condenser.
okay, so we'll discuss later. In this what I have just told,
Yeah.
there is no problem, no
Yeah.
cross question, everything you people
No problem, no
understand.
problem.
Okay,
Yeah.
all right, no issues, no issues. Now go. Now what we are having, high pressure and slightly lesser temperature. That's why I have shown this arrow bigger. This arrow is little smaller than this arrow. So high pressure and slightly lesser temperature and saturated liquid after condenser. Then there is a dryer, okay, which contains silica gel, okay, to absorb if any moisture present in the refrigerant. Okay, now this high pressure liquid refrigerant moves into the thermostatic expansion valve. Okay, this high pressure liquid refrigerant at point 3 move into the thermostatic expansion valve. Okay, what is thermostatic expansion valve? It is a throttling device, okay, which regulates the flow of refrigerant through sensing bulb connecting via capillary tube. Okay, it acts like an orifice where sudden drops in pressure and temperature take place. Okay, where sudden drops in pressure takes place, and as the pressure drops, the temperature of the refrigerant also decreases. I will be telling now, explaining when the pressure drop, why the temperature of the refrigerant decreases. But let me show you what is orifice. Okay, let me search where I have explained how sensing valve working of evaporator. Why here why, okay, why temperature in TEB the saturated liquid refrigerant converted into mixture. First let's see, it acts like an orifice. So you must be seeing this picture, guys. Orifice is like this, a small hole that will be here made up. Okay, just consider this, through this hole the liquid going into a larger volume and having a free expansion. Okay, because of this free expansion, pressure decreases. And you know, guys, when the pressure decreases, even for any case, for example, take water, if you will decrease pressure of water, it will evaporate faster, it will boil faster, better to say boil faster. That's what we do in freshwater generator. We decrease the pressure of seawater by Venturi effect, so it will be easier to make it into vapor. So what happens, due to this decrease in pressure, it is very easy to become some portion of the liquid into convert into the vapor because of decrease in pressure. So when the liquid, some of the portion of liquid, saturated liquid refrigerant changes into vapor state, that takes the heat, latent heat from the remaining refrigerant. Okay, by the they take heat from the remaining refrigerant and changes its state into a vapor refrigerant. So from there we get mixture of saturated mixture of liquid refrigerant, liquid and vapor refrigerant. Got it, guys? Any doubt? Any people want me to explain again? Sarfaraz, all clear?
Got it.
Salman, clear?
Yes, yeah, got it.
Okay, okay.
Yes.
Now understand.
Then how is pressure decreasing? Since
How is
area is decreasing, no pressure should increase.
area is decreasing? How? Area is decreasing, pressure should increase.
At the orifice.
See, it's going into the, it's a smaller area. Yeah, you can't you are applying Bernoulli theorem here. No, this, see, don't confuse it. Don't confuse it. It is expanding into a larger volume. Okay, okay, from through this smaller area. Okay, it's like an orifice. So in orifice, when it is goes free expand, in free expansion, okay, which effect here it is applying Joule-Thomson effect. I just avoid to take Joule-Thomson effect because to avoid any further confusion, because they in marine, the chief engineer which takes the interviewer, they are not very much of into concept, into deep concept, into they are, because that goes for mechanical engineers for competitive exams interview, but these are marine engineers, So they are not very much into deep things, what are the Joule-Thomson effect and all. They are just about knowing practical thing. So that's why I never said in front of interviewer mentioned this Joule-Thomson effect is applying here. Joule-Thomson effect, what it says, when the liquid flow in a restricted volume expand in the restricted volume, the pressure decreases as well as the temperature decreases also. Okay. And there is one thing I also avoid to say,
Okay,
that
again.
there one thing which can make confusion. I also want to say that since if the fluid will be ideal fluid, for isenthalpic process, the I am audible, for ideal fluid and for isenthalpic process, the temperature will be constant if there will be ideal fluid and there will be isenthalpic process. But here this refrigerant are real fluid. Ideal fluid means what? The fluid having no viscous force, the fluid having no force of attraction, no force of repulsion, no intermolecular attraction force or something. So I avoid to say this because of confusion coming a lot. So let's clear this again, guys. You have to just say that in this thermostatic expansion valve, it's a throttling device, it's acts like an orifice, it regulates the flow through sensing bulb, connecting wire, capillary tube. At the same time, it acts like an orifice where this pressure and temperature decreasement of pressure and temperature, or where sudden drop in pressure takes place. Okay, sudden drop in pressure takes place. Here you can see that this sudden drop. Okay, and it is a highly irreversible process. That's why we show in dotted line. Okay, I have also explained that why we show that dotted line. Many of the things I have, many smaller concept I have explained in the whole 32-minute video. This will be not like that. If you are explaining, if you are studying this, anything will be left. Okay, so I have covered every minute detail. So guys, I would request after this meeting session you go this videos also, and also if you want to explain what I explained in front of, if you want to know that why I explained in front of Marvin Brigjenga sir, I have did a other video, that is top 30 Anglo interview question and answer. That is mostly for Anglo but can be used for other interview as well with Evito Lorenzo. So that videos will help you also. And you must be aware of that the interview nowadays is so tough that Salman is the example. He got rejected 3 times by Braganja sir. So you can assume nowadays, in spite of Salman is a very good candidate after listening his explanation and all the things. So guys, you have to be perfect. Okay, now where I was, Sarfraz, where I was. Okay, this pressure and temperature reduction in
I
thermal.
also forgot where you were, bro.
Oh no, you just flow भावनाओं में बह गए. Okay, no worries, no worries. I am
मैं बातें सुनने लगा.
okay, no. This now understand this. This pressure and temperature reduction in, since in thermostatic expansion valve, this pressure is reducing. Guys, see this graph, pH graph. Pressure is reducing. Okay, and this temperature is also reducing. You can also tell the interviewer like, sir, if you see in pressure pH graph and TS graph, that you will get to see the dotted lines, that is decreasing temperature line. Okay, and also in pH graph that you can see. Oh, network issue, let's say. I want a clear picture. Okay, so here you can see. Okay, this process is thermostatic happening in thermostatic expansion valve. All right, so here pressure is decreasing, temperature is decreasing, and I just explained the saturated liquid. This saturated liquid, this point, it is at saturation dome at point, so it will be a saturated liquid, and it is in the falling in the middle of saturation dome. So I just explained earlier that if the curve will be, if the point will be falling in this saturation dome, it will be in the mixture phase. So from graph here you can have the clear picture, it will be in mixture phase in you going before the evaporator. Got it, guys? So from understanding from the graph is much easier. Now this low pressure, low temperature refrigerant mixture will enter into the evaporator, which is another type of heat exchanger, and it is located in the region where refrigeration effect is produced. Okay, here evaporator is the region where we get cooling effect, we get refrigeration effect. It is the region where we want the cooling effect. Okay, so for example, in a case of AC and all, we put this evaporator in our room and other thing, compressor and condenser thing out of the room. If you see the split window AC thing, got it? Now means this low pressure where refrigeration effect is produced, and this low pressure, low temperature liquid vapor refrigerant mixture extract the heat from surrounding and changes its phase. It will change its phase at constant pressure, okay, into a totally vapor refrigerant. Now see from graph, it is coming here, okay, coming here again at the one point. So it is totally vapor, just become a saturated vapor. Isn't, guys? This point lie on the saturation line, saturation dome line. Okay, this become a totally vapor refrigerant, and which causes refrigeration effect or cooling effect, because it takes out the, it absorbs the heat from the surrounding. You know, when the evaporation process takes place, you feel cool. You come in the room, sit under the fan, and fan takes all your sweat, then helps in evaporation of your sweat, and your sweat takes the latent heat of your body and evaporate. You feel cool. Isn't, guys? Isn't, guys? This is the same concept here. Just say it now. Sarfraz, getting it?
Yes.
All right. Now what is important to note is that refrigerant mixture should this refrigerant mixture should evaporates completely. Okay, this refrigerant mixture should evaporates completely and converted into the vapor refrigerant, okay, by the end of evaporator, like by here. Otherwise it can damage the compressor, as liquid is incompressible. This liquid is incompressible. Okay, so guys, here what we are seeing, that if by any chance this
Where sudden drop.
this one at point 1, if by any chance it is not totally converting into vapor, if it is not converting into vapor, this can damage a compressor. Okay, so what we do, since it is falling at this point, so what we do, we just superheat. Let me show this superheating thing from graph. We just superheat. Here you are seeing that from point 1 I have just extended this thing in pH curve. So we just superheat. See, I am superheating. Okay, and to avoid the mishap, okay, and this process will go like that. Yes, after superheating,
like this,
the
the
compressor
same
has to do work more
Start like
from the graph, but it is important because we have to save the compressor, and we superheat 5 to 8 degrees Celsius, and that superheating is ensured by what, Salman? This superheating is ensured by this sensing bulb.
Sensing bulb and thermostatic.
Why that is connecting. Okay, so now my question is, if we get a more superheat, not 5 to 8 degree Celsius, if we get 20 degrees superheated vapor, that is also not a good thing. Compressor has to do a hell lot of work, isn't it, guys? So how sensing bulb will work, and how this expansion valve, throttling valve will close and open. It will expand on shrink or what? Salman, would you like to explain?
Yes, sure.
Mm.
So in the sensing bulb, the same refrigerant liquid is there. So if there is more degree of superheat, then the refrigerant in the sensing bulb will evaporate, and it is balanced by spring pressure and evaporator pressure in the thermostatic expansion valve. So if more refrigerant evaporates in the sensing bulb, then it will exert more pressure on the diaphragm, and it will open the spindle so that more refrigerant enters, and the temperature is lowered, degree of superheat.
Okay, what an explanation! What an explanation! So, guys, you see, I think it's a bad luck for Salman that he got Brijingar sir for all the 3 times. If you would have gotten the third time the other interviewer, then he would have get selected. Because Braganja sir, if you go for second time, third time, Braganja sir expectation from those candidate who is appearing again becomes high. He asks anything. He asked them also auxiliary engine safety, main engine safeties. So for Anglo, for Braganja sir, you need to prepare yourself so smartly that you clear your first attempt, because it will be easy to clear Braganja sir interview in first attempt. Okay, because he will be thinking that you are appearing first, so he will be asking you not that much upgraded question like advanced question. Got it, guys? So after sensing bulb, the process, this low pressure, low temperature. See, one thing I want to tell you guys, after this evaporator sensing bulb just told by this Salman, we have this the same low pressure, low temperature, because the phase change takes place, and at phase, when phase change takes place, the temperature and pressure is not increasing. Okay, okay, see, after this the pressure and temperature will be remain same here. After this, after evaporator, see, pressure is same and temperature is same. But in a case of compressor and condenser, since process isobaric in compressor and condenser, after compressor in condenser, but temperature is reducing, because at the also in condenser phase changes taking place and temperature is also reducing, and evaporator in evaporator also phase changing taking place, but temperature is not reducing. So why is this happening? So let's understand this. Because in compressor to condenser, this has to bulk cool for superheated to saturated first, and since it is out of saturation dome, so this pressure is will be constant, this pressure is constant, but at this time the temperature is not saturation temperature. Saturation pressure, saturation temperature will be in this only saturation dome. So at this time from 2 to 2 dash, after compressor superheated vapor has to come with first saturated vapor. At this time this temperature is decreasing, and that is the slightly decrement of temperature. But here in a case of evaporator, after thermostatic expansion valve, we have the mixture that the phase change is taking place, that is falling in saturation dome. This is the saturation pressure, saturation temperature, that's why temperature is same. Got it, guys? Got it, guys?
Yes.
Now what was my cross
Yes.
question? Just after this the cross question is asked. What is the cross question asked? Let me tell you. I have just asked temperature at evaporator coil, and why this cross question is asked? Because he want to understand the concept behind this cross question. Okay, not that the exact value of temperature at
Hello, this is
temperature
GYAN.
at evaporator coil. Okay, so this is the video that I have uploaded today. Okay, that is, you will get to see it, where I have mentioned all the things. See, chapters, VCRS compression. First you have to watch why candidate got rejected earlier on temperature and evaporator coil, what actually the interviewer wants to hear after asking temperature and evaporator coil, mostly commonly used, everything I have covered. Pressure at condenser, pressure at temperature, temperature at condenser coil, I have covered that. For a safety reason, if anything come across to you, you can handle that. Okay, so I am just explaining in short. Actually, this temperature and evaporator coil concept is that mostly depends on which type of refrigerant we are using, and also you have to tell that for this refrigerant the temperature is this. So for that you have to refer this video. Okay, and since I am having my laptop battery so low, you can see here. Okay, my laptop can get shut off any time. So guys, I think, any cross question guys? I think I should conclude. Yeah, Amson, go ahead. Yeah, Amson, go ahead.
Yeah,
Ask.
again, if the interviewer asks for to explain the VCRS system, can I tell him to wait just to draw the system on the page and then try to explain him?
No, no, without drawing you can also explain. I have just explained now. What I explained exactly, I have shared
So
my.
things becomes more clear, no?
See the imagination. Keep your imagination
With the
power. So
graph and all.
yeah, but so interviewer takes only a 10 to 12-minute interview. He don't have any time. If he is not interested in you, he will not permit to you. He will say try to explain like this only. So I have explained that, and you will go to see this what I have explained, and he was very much impressed. It was the last question that I explained to him, Bradanja sir. Okay, and I am just referring you the video that what I have explained. Okay, and you can see my screen. Sorry for the bad network guys. God.
I want to add something,
Yes,
but
Salman there.
you should also practice to draw it. Yes, yes. I am saying
Yeah,
you should
yes,
also
because he can
practice to
ask,
draw
he
it
can
fast,
ask.
because sometimes ask, because he had asked me in my interview, explain with diagram.
Yes, he's asked. He generally asked. I never said that you should not. You should be practice of these 3-4 diagrams for Anglo mostly. That is centrifugal pump diagram, gear pump diagram, VCRS diagram for Brijanga sir. This 3 diagram for Rishi Rana sir. What I have to make a proper dedicated video for 2 more interviewer. I will be doing that with Avitul Lorenzo. So guys, and valve timing diagrams, and these are the some turbocharger diagram. Okay, these are the some diagrams you need to be aware of. And let me show you the things, because sometimes people know the concept and don't know what to say, that interviewer will be satisfied anything that is already tested up. So you get these things that is already tested up by my friends and me, what I have explained, and we got selected. This is one of the most popular video from our YouTube channel, and people till now people have seen this video. Can anyone imagine how much hours this video has been seen? This is 50 hours. This video has been seen approximately 50 hours.
If you are running
Okay,
a business,
so this is the top 30 question, and in top 30 question I have also mentioned the chapter for every question. Okay, so you don't have to waste your time for all the question which you know on a prior basis, which you know earlier also. which you don't know, you can refer to this chapter. Okay, just like one asked explain VCR cycle, what to say without without not making diagram, okay. So Amston or something, who people are asking, I have just explained the same explanation which I have explained while in interview. Here this chapter number 25 you can refer. Okay, okay guys.
Gyan, I have one question.
Yes, I was just about to ask you. Yeah.
Yes,
Okay, yeah.
yeah. How does the moisture come from? From where does the moisture come from in the refrigerant line?
Hmm. When we maintain, na, when you overall maintain, okay, uh, so at that time there is a most chance, and that question has been asked by Hifazat Ansari. Okay, from where moisture comes, and where and what is the like how you get to see that moisture has come, how you will notice. So there will be a and in a case of domestic refrigerator, how moisture come. Sometimes domestic refrigerator door open, door not closed properly, then from air got some moisture, they comes and form the layer of insulation, and frosting of ice formation takes place, that acts like an insulator layer that decrease the efficiency, because heat transfer, they affect the heat transfer process. That evaporator coil, you must have seen the ice frost formation, is it? So you got it Sarfraz.
Yeah, but moisture will get inside the refrigerant line or what?
See, the moisture, you are more like saying that how this moisture get into the pipes, condenser pipes and all, na? You are more
Yeah, yeah,
after.
yeah, yeah.
Okay,
Because
so
we are using dryer, so
yeah.
where is it coming?
See, I just told you na what Hifazat told, and I am also telling the same. When we maintain for a large plant, when we after living this system without for a longer period of time, so from where there can come, okay, in maintenance also there can come when we overall open up the system, okay. So these are the things.
Okay.
Got it. When you can say that when we maintain,
Yes.
means when we open up and for the cleaning purpose, okay, for overhauling purpose, and the second is you can say that for living a longer period of time, okay, in a region of moisture, and since water can get into everywhere, na, okay, so it is not that much. So for that that region the dryer is there, na,
Okay.
and because of leakage it can also get into, because
Okay.
of leakage. So these are the some questions that is very subjective, because some of the one person got rejected on this question, what are the effects of, like how this discharge valve, like we have safety in compressor, one safety is that relief valve, okay, is it or not? So it is to release the excess pressure to save the compressor. There is a relief valve at the discharge side of compressor. So one guy asked from Brijanga sir, so what are the factors that to having a excess pressure, having a more pressure, having a larger pressure in compressor, so how it can go from the set value, the pressure can go. So how will you say this answer, Sarfraz, if you have to answer?
Can you please repeat the question? What was the question?
That I am just saying that there is a safety device, a compressor, okay, in compressor there is a safety device, that is relief valve, okay. Relief valve is works when there is a
Okay.
large pressure in compressor, from the set value goes the pressure of the compressor goes above from the set value, okay. So at that time, safety relief valve works. Okay, so I am asking that what are the conditions, what are the condition of going this pressure above the set limit, set value.
I think the discharge value of the compressor of discharge valve will shut. Compressor discharge valve will shut.
Mm. Yeah, this
Yes,
can
if
be
the pressure will not be able to get
uh,
transfer.
see, there are subjective thing. You
Maybe
can
because
say
of
that,
some leakage, blockage in the pipe.
yeah, you can say that because of some blockage, because of some restriction, because of the, because of so many things. Like also you can say that if compressor falls in some of high temperature region, because of high temperature, pressure can also go up very high. Okay, at a time that candidate got blank and he was not able to think that what should I say, and he was like, I haven't heard of this, I got to ask and never imagined that this can be asked to me. And he was blank, and as you know, Brajanga sir asked only 3 to 4 questions mostly, and then he said reject. So these are the things that is very subjective thing. You have to think on a general basis how can this happen and all, and interviewer can get satisfied. Got it, guys?
Gyan, I had a question for you.
Yeah, yeah, go ahead.
Yeah, where does the refrigerant accumulate after the plant has been shut down and all? Which component?
Okay, so it can accumulate anywhere. If I have to ask, and I will say, but we see this at evaporator coil. Okay, and see accumulation is taking place. I just got an idea that since evaporator coil is having the low temperature, so the moisture will freeze and that will accumulated at the evaporator coil. My answer would be like this only. And okay.
Gyan,
Hmm.
why do we need to refill the refrigerant? Like, where does the refrigerant go? Does it
Charge of
leaks or
no, refilling the refrigerant, charge of refrigerant. Why we do need refilling the refrigerant? Anyone?
yeah?
Salman?
Due to leakage. Sometimes the after prolonged use it might leak.
Due
Only
to
because of leakage, right?
And also in case of like if blended refrigerants are used, so like
hmm,
after a very long time then the components may separate,
hmm.
and that is why then we have to discard that refrigerant and use new refrigerant.
Okay.
All right. So for today's session, that
Yes.
was it, guys. Anybody want to what will be the next topic? Anybody like to suggest? That is the most important topic.
I had one more question.
Yes, Salman, go ahead.
Boilers.
Boilers or IC engine, we can.
So like
Hmm. Yes.
Yeah, we can go IC engine too.
Okay. So boiler, IC engine.
Anyone?
Okay. Yes, Salman, go ahead.
so like in domestic refrigerators the expansion device is capillary tube, right?
Hmm.
Instead of thermostatic expansion valve.
Hmm.
So there how we ensure that 100% vapor goes in the compressor, what like safety is there? So here there is thermostatic expansion valve, but in case of domestic refrigerators what is there?
I don't have, I think the same thing is there. I am listening first time that there is no thermostatic expansion. I have seen the capillary tube, that is the tube that is very longer, and that is at the back side of.
Yes.
Okay.
So both things are there in the domestic refrigerator,
I am
the capillary
sorry
tube
for the
and the
time.
thermostatic expansion valve.
Let me write it. So
Uh,
I will cross check,
in
but
refrigerator, we have to maintain constant. Yes.
on.
Sir, in actually in air conditioner, our requirement will be different. Means we have to change our temperatures regularly for that your comfort zone. In refrigerator, we have to maintain constant temperature. So there is a calculator we use it to flow that constant
Yeah,
refrigerant.
yeah. He is saying that in a case of air conditioner, since the bodies we are having a different temperature, okay, so the and it is it cools the continuous thing, okay, continuous body or continuous source, the continuous heat source. But in a case of refrigerant, we have some certain storage that needs to be maintained at constant temperature. So for that reason, that can be the answer. Okay, so guys, I think we should wind up for the time being. We can discuss this in separate sessions because we'll go above from the dreamer package concept and other concepts, and we can, because we are not here to do so much research, we can discuss the things that is going above from that is coming naturally and not from thinking so much. We can discuss here, because I am also learner. If something is coming up and I am not knowing, I will not tell you any false information. I will directly say that I don't know for the time being. I will do my homework and we can discuss that question already. We'll discuss this question in future meetings. Got it, guys? From that we learn. Okay, we all are learner here only. So guys, feel free to ask anything and we can discuss in later sessions. Okay guys. So Sarfraz, Salman, Amstan, may I take your permission everyone to close this meeting session, and tomorrow meeting session.
Yes, yes.
Okay,
Yeah, yeah,
so
Gyan. Yeah, thank you, Gyan.
okay, welcome
Yeah,
all.
thank you.
So tomorrow we'll be discussing, since after 10 days I will be leaving here. I have my flight. Okay, after a week, just only 1 week is there. So I will be discussing the most important things with you guys before going there, and then after your meetings will be taken by another uh, uh, people, that is Evito Lorenzo and other peoples who have already qualified the interviews for various sponsorship. Okay, so guys, yeah, tomorrow session will be based on IC engine difference between two stroke and four stroke only. Okay, we will be discussing the major difference, because some of the time they ask difference between two stroke and four stroke. Some people after saying 3 to 4 is difference, they got blank and they got trapped while cross question. So we are having, we will be discussing the how we would say that we can say these differences, because there are huge differences and there are huge number of differences. So how and when we should say that difference first and that difference later. Okay, and for that you can refer this video. Okay, on a prior basis, so that our time will be saved and our time will be saved. That is, you are seeing my screen.
Yes.
Okay, so difference between two stroke diesel engine and four stroke diesel engine. Okay, so I have told about 15 differences along with the cross questions which I faced. Okay, so you can refer this two chapter, and whomsoever is more excited about their interview preparation, they can refer all. But tomorrow we will be discussing the differences between the two stroke and four stroke. All right guys, so thank you for your time and be dedicated guys. Okay, so thank you once again.
Thank you very much, Gyan.
You're
Thank you,
welcome.
bro. Good night.
Good night, and this was Gyan signing
Thank
off.
you, Gyan. Good
Bye.
night.